What's next for Blue Origin after the explosion? Finding overly massive black holes at the early universe. Could dark matter be made of comets? And a galaxy that just isn't rotating? All this and more in this week's Space Bites. Last week, we reported on the New Glenn explosion that we saw out at Cape Canaveral, pad LC-36A. And it was a big explosion. It was a mushroom cloud. And now we found out more information about the damage that was caused to the launch facility. And again, when you look at the explosion, you're seeing this giant fireball. Everything is just wreathed in fire. And that can't be great for all of the facilities that were all around it. Well, according to Blue Origin, it's not that bad. They looked at the propellant tanks, they looked at the water tower, and everything seems to be okay. The launch gantry is definitely damaged, and the mobile transporter, which carries it from the assembly building to the pad and also puts it vertically, that's going to require a rebuild. But Blue Origin said that this is something they were hoping to rebuild anyway, so I guess no harm done. According to Blue Origin, they say it's only going to take them about 6 months to get to the point that they can launch rockets again. But independent analysts looking at this say it's probably more like 12 to 18 months. And keep in mind that Blue Origin is building a second launch complex at LC-36B. And so it might be that they're able to return to launch at this other pad while they continue to make all of the repairs to A. So that might still get them back into the game. But the thing that's missing in this entire process is, why did it happen? And we still don't have any information about that. Again, when you analyze the explosion, you see it beginning down at the engines level when they were starting the hot fire test, and then the explosion enveloped the entire rocket. Was it caused by the engines? Is there a problem with BE-4 engines? We don't know. And with the BE-4 engine, it's not just the New Glenn rocket. This same engine is in the Vulcan from United Launch Alliance. So it could be, if there are issues with the engine, then they're going to have to take a look at all of the rockets that have these installed, anything that is based on this engine. So while Blue Origin is giving us an optimistic view about how they're going to be able to get back into operations, we're going to wait and see and watch and report as key milestones are actually hit. And of course, one of the reasons why we're watching Blue Origin with interest is that they're part of the Artemis program, that they are going to be supplying landers for upcoming robotic missions to the moon, and eventually, hopefully, a lander that can actually carry astronauts to the surface of the moon. And so we got a great test from Blue Origin this week where they put their Blue Moon Mark 1 lander called Endurance into this enormous chamber that they have at NASA. They call it Chamber A, and it replicates all of the features, all of the hardships of being in space. It replicates the temperature variations, the vacuum, and allows them to test to find out, will all of the seals and all of the pressure vessels and every part of the spacecraft handle this environment? And it's so big, they can just put entire spacecrafts, lunar landers, things like that, into this chamber and test it. And they went through the testing process, and the lunar lander came out the other side, no problem. So the lander is moving towards being fully operational, while the launcher could have some setbacks. The Blue Moon Mark 1, this is what's going to be carrying a couple of robotic missions to the surface of the moon soon, or was supposed to carry them soon, but now who knows how long the delay is going to be. But anyway, and then with the Mark II, this is going to be their landing system for the upcoming Artemis mission. And so you've got SpaceX, it's supposed to be delivering the human landing system, which is a modified SpaceX Starship. And then you've got the Blue Moon Mark II, which is going to carry astronauts. And this tension, multiple providers, should allow NASA to get some kind of landing system for the Artemis 4 mission, which was scheduled for 2027. But we'll see how realistic that continues to be. And in fact, they're supposed to fly on Artemis 3 as part of that test. And so will they be able to actually launch this thing into orbit? The timelines are all weird now. Anyway, we've got a story about the testing of the Blue Moon Mark 1 by Mark Thompson. Mark Thompson. Anyway. I've mentioned many times about how excited I am about the Nancy Grace Roman telescope. Of course, the crazy part is that they are ahead of schedule and on budget. which is wonderful. And so we should actually see this telescope launch in September 2026. And so NASA revealed their final analysis of the main mirror of the telescope. They've got some cool video of them doing final inspection on the primary mirror for Roman. And of course, this is the final time that humans are going to look at the mirror of the Roman telescope. From this point on, it's going to be out in space. So only the universe will be looking at the mirror. Now they're going to package it up, send it to the Kennedy Space Center, and then prepare it for its launch again in September, like 4 months from now. So originally they've been telling us it was going to be September 2026. Now it looks like it's going to be the end of August. They just keep pulling the schedule forward. This is some kind of flex. And of course, when the Nancy Grace Roman telescope launches, it's going to fly to the Earth-Sun L2 Lagrange point, which is about 1.5 million kilometers away from the Earth. It's going to have this giant wide field of view. It's going to be scanning the sky in infrared. It's going to be contributing to our understanding of dark matter, dark energy, the evolution of the universe, and it's also going to be able to help find exoplanets, Jupiter-sized exoplanets orbiting around sun-like stars. I could not be more excited about this mission. We've got a story about this from Lawrence Tugnetti. Our understanding of the early universe is really coming into focus thanks to the James Webb Space Telescope. And one of the surprising discoveries are these overly massive, supermassive black holes that right now in the universe, most galaxies contain supermassive black holes, but the mass of the black hole as a ratio to the rest of the galaxy is like less than 1%. You know, people always think that the supermassive black hole at the center of the Milky Way is like this giant anchor, but it's just a fraction of the mass of the galaxy. As you go earlier on in the universe, older galaxies have a larger fraction of their galactic mass in the supermassive black hole. But astronomers are finding galaxies early on in the universe where the supermassive black hole accounts for 1%, 10%, close to half of the mass of the galaxy. And this was a bit of a surprise. But whenever you find something like this, where you're very far away, it's the very limits of what James Webb can see, you have to wonder if this is some kind of survivorship bias. That you can only see the things that are extreme. You don't see the regular stuff that's just in the background that is normal. You're only seeing the outliers. Think about, say, the discovery of the first exoplanets orbiting around a sun-like star. These were the hot Jupiters that were yanking their stars back and forth with intense gravity. And so how do you know if what you're seeing early on in the universe is normal? So astronomers used a really interesting technique to try and get a sense of what they were seeing with these overmassive black holes is sort of the normal case. They looked at surveys of galaxies done by James Webb, and there's a bunch of these now that we've been reporting on. And you not only have the galaxy that James Webb is looking at, and some of them are very close, there is also a lot of other galaxies and stuff and their gas in the background of that image. And so the astronomers did spectroscopic analysis of the backgrounds to get just a general sense of what kind of glow is there early on in the universe. And they found that these galaxies that we can see are probably skewing the results, that this isn't normal, that these are outliers, and that the true number of overly massive black holes is probably closer to what we experience in the universe around us. Got a story about this from Evan Goff. And then in addition to the discovery of all of these black holes in the early universe, astronomers have also found examples of galaxies that have shut off their star formation surprisingly early. Like this is a time in the early universe when there's tons of gas to go around. Galaxies should be forming stars like crazy, and many of them do, but there are the occasional ones that are just, they're done. They've run out through all their gas and now they are no longer forming stars. Why? Well, one possibility is that the supermassive black hole at the heart of these galaxies is putting out really powerful stellar winds that are quenching the star formation in the galaxy, essentially blowing material away before the stars can gather together and ignite as new stars. The other possibility is that these galaxies are the results of mergers. So you had two galaxies that crashed into each other, the gas clouds piled up, and that led to furious star formation that sort of burned through its fuel very, very quickly. And there's another kind of galaxy that has the opposite situation. These are called dusty star-forming galaxies, and they can produce hundreds of times the number of stars that the Milky Way forms every year. Like the Milky Way forms about one star every year, and some of these dusty galaxies can form about 500 stars per year. And so in a new paper, astronomers have used observations from James Webb, and they are leaning towards the idea that these early quenched galaxies are coming from the results of mergers. They were able to see sort of the wreckage of mergers in the vicinity around these early galaxies. I've got a story about this from Evan Goff. Okay, this next story is out there, literally and figuratively. And so I just need to prepare you in advance that this is not scientific canon, but it's a very interesting idea. So one question they get all the time when we talk about dark matter is people are wondering, well, could dark matter just be things that we can't see, like rogue planets? And this is an idea that astronomers have had, and they've had ways to be able to find out whether or not rogue planets would account for the dark matter that is influencing the gravity of a galaxy. They look for gravitational microlensing to watch if stars are being lensed by various objects. And if you had 10 times the mass of the Milky Way contained in rogue planets, then you would see a lot of these microlensing events. They don't see the events, therefore they can kind of rule out that it's rogue planets. But now we have a sense of the number of exocomets that are passing through the solar system. I mean, think about it. We have 3 events so far. We have Oumuamua, we have Borisov, and now we have 3I Atlas. And 3I Atlas was interesting because it is very large and massive compared to Oumuamua and Borisov. You can sort of count the other 2 as rounding errors to the mass and size of 3I Atlas. So astronomers were wondering, we were able to find these objects in the solar system. Does that give us a sense of how many there are out there? And so they took this single data point for 3I Atlas. You never want a single data point, but this is what they did. And to account for this data point, you could have stars that are throwing off 15 to 50% of a solar mass's worth of material during their formation into the general Milky Way, and that this would actually account for a sizable amount of hidden mass in the Milky Way. This could go down to 0, of course, or this could be a very interesting trail to go down. We're going to know more with observations from the Vera Rubin Observatory, because it's going to find many more exocomets passing through the solar system and then get a much better sense. Instead of 1 data point, we'll have 2, we'll have 10, we'll have 100, and that will pin down what is the possible mass of exocomets and exoasteroids in the Milky Way coming from this. And like if it's a large number, then it means that star formation and planetary formation is a much messier process than we had originally thought. That, in fact, through the process of a star forming and its planet settling down, a tremendous amount of material is thrown back out into space. And of course, this can be used to check against other dark matter experiments as well. So it's, again, very speculative, but I kind of enjoy that we're in the early days. Someone thought of something very interesting, clever, and now we'll wait for the data to catch up to it. Got a story about this from Andy Thomaswick. Every week we do a vote on our channel where you tell us what you thought was the most important space news story of the week. And the winner last week was boom. So thank you everyone who voted. We are going to put this week's poll into the post tab here on our channel. But of course, subscribe to the channel, click on the notifications bell, vote early, vote often to train the algorithm. Tell us what you thought was the most important story of the week. Everything in the universe appears to be spinning. The Earth is spinning, the sun is spinning, the solar system is spinning. The Milky Way is spinning. It's just one of those things that you get as conservation of angular momentum as things come together. But now astronomers think they found a galaxy that is not spinning at all. The galaxy is called XMM Vid1 2075, and they're seeing it less than 2 billion years after the Big Bang. And instead of having this flattened structure that you get because it is rotating, it looks like a bunch of angry bees that are just orbiting around each other. So how do you get something that isn't spinning? Well, clearly these things are very rare because everything else seems to spin, but the astronomers think that you got a collision between 2 galaxies that happen to be moving in exactly the opposite directions and opposite spins. And so they cancel each other out. And so you ended up with a bunch of stars that are now just orbiting around a common center of gravity, but without that spin to flatten them out. We've got a story about this from Mark Thompson. The Very Large Array is this huge field of radio telescopes in New Mexico. It's one of the instruments on my bucket list that I was finally able to get to about 15 years ago. And it's absolutely incredible. If you've seen the movie Contact, you know, where Jodie Foster's sitting there with her headphones on, she's listening to aliens talk to her. She's standing in front of the Very Large Array. And the Very Large Array is a world-class observatory. It can sort of do individual observations with different telescopes at different targets, or the telescopes can work as a larger interferometer. You know, think about the Event Horizon telescope, all these telescopes working together like a telescope the size of the separation between them. And the telescopes are on rails. So they can move them farther away from the center and make a bigger telescope or a smaller telescope, which is really cool. But it is aging and there's big science challenges coming. And so astronomers have been building the next generation Very Large Array. And this is a version of the Very Large Array that will span 8,000 kilometers, putting telescopes in Mexico, the US, Canada. It's going to be a gigantic version of the Very Large Array, and they will all work together and do separate observations. And now astronomers have tested the first of a new prototype of the next generation Very Large Array. And so they tested this new radio telescope, which is still located at the Very Large Array. You know, they start the prototype close to home, but they were able to look at the sun, the Crab Nebula, and they were able to look at a bunch of other astronomical objects, and it worked as planned. And so now, over the coming decades, we will see more of these telescopes deployed farther and farther away from the center point. Eventually, there will be this giant radio telescope spanning thousands of kilometers. Got a story about this from Matt Williams. I hope you're enjoying this week's episode of Space Bites, but you probably had to watch an ad if you're watching this on YouTube. As you know, we don't like ads. We don't think you should have to endure them. And so we have put this entire episode over on Patreon so you can watch it completely for free without ads. You don't have to sign up. Don't have to give us any money. You just watch it over there. And to encourage you to do that, to get into the practice of watching our videos without ads, we have added one additional story to this week. And this week's bonus story is calculating the maximum mass for neutron stars. So I'm going to put a link down in the show notes so you can access that version of this episode. And of course, this is just a fraction of all of the stories that we're covering on Universe Today. The number of articles that we're writing is just growing and growing. Now it is between 40 and 50 articles a week on Universe Today from a wide variety of writers. But if that's like too much news to stay on top of, I write my weekly email newsletter, which goes out every Friday. I write every word in the thing. There's no ads. It's completely free. You can sign up. Go to universetoday.com/newsletter. I had a bunch of questions about things that I reference during these videos that I want to explain. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Caradon, Chuck Hawkins, Commander Bailock, Dark Fingit, David Gilton, David Matz, Enthralling Reading and Math for Toddlers, Eric Lindstrom, Evan.pro, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Marcel Sitz, Michael Marcel, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Rankaidu, Richard Williams, Sean Sargent, Stephen Fadler-Munley, Team 49, Telescopes Canada, Vlad Chiplin, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So a little housekeeping. I've had sort of very similar questions get asked a bunch of times. So I want to sort of explain how this works. This came from Cam Kier. When you say you've got a story on this from Mark, where is that story? So when I say I've got a story from Mark, it's because we have a writer at Universe Today named Mark Thompson, or Brian Koberlein, or Matt Williams, or Evan Goff, or Andy Thomas. Right? Like we have a big team of writers on staff, and they are writing articles on Universe Today. And then we are basing this episode of Space Bites on the news that we're reporting over on Universe Today. And so if you go down into the show notes below the video on YouTube, you're going to see links to each one of the articles that I'm referencing. And then you can go from there to the actual papers that the writers are referencing. And what's cool about this is that we can put in the the time codes for each one of those stories, and then those turn into the chapter markers here on our videos. And so we're trying to give you a way to reference the work that we are bringing up. And I also think it's really important that I let you know about the people on the team. It's not me. I'm their publisher, I'm the editor, but it is the individual writers who are out there doing the research and the reporting that I'm relying on to be able to do this episode of Space Bites. Caden V, silly question, but what on earth is the post tab on YouTube? I mentioned this about the vote every week, that we put this into the post tab on our YouTube channel. So if you go to our page on YouTube, there's a bunch of tabs. You can see the videos, the shorts, which we don't do, and the posts. And those are typically all of the polls that we're running every week. Although I'll also put in pictures, images of wildlife that I'm finding on my property, and random questions or thoughts that I have. So there's more to the post tab than just the polls, but that's the main thing that we do there. And that the YouTube algorithm, the way it works is that the kinds of things that you tend to do on YouTube, it will use that as a very strong signal to then throw more of that at you. And so if you hear me talk about the polls and you never see them every week, all you have to do is just go to our YouTube channel, go to the post tab, just vote on a bunch of past polls, and then YouTube will go, oh, finally, you've told us something we can use. And then you should, if the algorithm is working correctly, see those every week. The post tab isn't always available on every interface. So if you're watching on TV or like the iPad, you might not get access to that. But if you're watching on computer or mobile, you should be able to find it. All right, I hope that explains it. We'll see you next week.